Hello, my name is Tim Tague. I'm going to be discussing ESE 403 Exam 3 Problem 2, the business problem as well as the linear programming model and the solutions and how we derived it all. So in this problem, there's an investor that has foreign currency and investments in foreign countries, and he realizes that the value of his investments in foreign countries is going down as the value of the foreign currency is going down, and he wants to convert and get all his money back in US dollars and then invest in US bonds. And in the process, he deals with transaction limits between different currencies as well as um, transaction fees, depending on which currencies he is exchanging for. And there are obviously different exchange rates between different currencies. So there are many things present. We decide to formulate this program or this problem as a linear programming model, a minimum cost flow problem, and to identify what we start with and how we can convert this all to US dollars in the most efficient way possible, paying the fewest transaction fees, so that the fewest amount in transaction fees, so that we have as many US dollars as possible at the end to then invest in US bonds. So I guess I'll pull up here, as you've seen, is the um, linear programming model that I've developed for this problem. So he starts with 1.2 billion Japanese yen, 10.5 billion rupiah, and 28 million ringgits. And these are the conversions to US dollars. So the reason I have 15 million then is when he converted to Japanese yen, he had $15 million. The price of the yen has gone down. He now has 9.6 million US dollars worth of yen, his 1.68 million dollars worth of rupiah, and 5.6 million dollars worth of ringgits. As you'll see later, these are the variables I've defined: A for yen, B for rupiah, C for ringgit, and so on. I then define a bunch of decision variables that will be used for these conversions. So, for example, XAB is converting from yen to rupiah. XAE right here would be converting from yen to Canadian dollar. Obviously, at the end, we want everything to be converted back into US dollar, which is D. So we hope that everything will be converted to US dollar in an efficient way possible. As you see, all the from any currency to any currency, I define all these decision variables: from euro, from pound, from peso. The reason I have most likely US is we assume that once it gets to a euro, pound, or peso or Canadian dollar, the next step would be to convert to US dollars. However, the problem statement, it doesn't state that we can't convert between these or back from these to a ringgit, rupiah, or yen, although we don't expect this to happen, but it is a possibility. Moving on in this minimization function, we basically use every single decision variable defined above multiplied by the transaction cost to convert between said currencies. So, for example, there is a 0.5% transaction fee to convert from yen to B, which is rupiah. Yes, to convert from yen to rupiah, there's a 0.5% transaction cost, so 0.005 in decimal form. And as you can see throughout this whole minimization statement, you can pick any one and kind of just double check. So for example, E to C, this would be converting from, let's check, Canadian dollar to ringgit. There is a 0.7% transaction fee. So by minimizing this, we are minimizing the total transaction fees, which is what we want. We want to get back into US dollars while losing as little as possible in the transaction process. So we minimize, so there's all these possible transactions multiplied by the percent taken off for the transaction, we minimize that. Now, obviously, there are constraints. Constraint one is on Japanese yen. We start, as mentioned, with $9.6 million worth of Japanese yen. XAB, XAC, XAD, these are all the lines that leave from Japanese yen. A to B would be yen to rupiah. A to C, yen to ringgit. A to D, yen to US dollar. Everything that leaves as a Japanese yen is bounded by $9.6 million. And it must equal $9.6 million as we want to convert everything from yen and ringgit and rupiah back to US dollar. So as you'll see, as mentioned prior, we had $1.68 million worth of rupiah and $5.6 million worth of ringgits. So we must convert every single dollar worth of yen, rupiah, and ringgit back into US dollars. So everything that leaves as a yen to any transaction, whether it's going directly to US dollars, AD, BD, CD, or to other currencies, we need to get rid of every yen, rupiah, and ringgit. As mentioned prior, there are also transaction limits. So for example, as stated in the problem, you can only convert a certain amount of yen to rupiah and a certain amount of yen to US dollars. There are limits that the government sets. So these limits were in terms of 1,000 US dollars. So the limit for converting yen to rupiah, or sorry, yen to rupiah, A to B, was 5,000, and then multiplied by 1,000 US dollars worth. So 5 million. So you can only convert 5 million US dollars worth of yen to rupiah. You can only convert 2 million of US dollars worth of yen straight to US dollars. So as mentioned, we had $9.6 million worth of yen. You can't just do one simple transaction straight to US dollars because there are transaction limits. Again, there are transaction limits for rupiah. You can see all these constraints here. And there are transaction limits for ringgits. You can see all these constraints here. They're very similar to the constraint for yen, so I won't dive into too much about them. They're just different numbers depending on which currency exchange. Next, we define limits and constraints on the kind of in-between currencies. So obviously you start with yen, ringgit, rupiah. The end goal is US dollars. To do so, you're going to cross through Canadian, euro, pound, Canadian dollars, euros, pounds, and pesos. So basically what this is saying is that everything that comes in and gets converted to a Canadian dollar needs to leave and be converted to something else, whether that's a US dollar or something else. Everything that comes into Canadian needs to leave an equal amount. So here, E is the variable I define as the Canadian dollar. So as you can see, these positive variables, this is from yen to Canadian dollar, rupiah to Canadian dollar, ringgit to Canadian dollar, and so on and so forth. Whatever comes in to Canadian dollars needs to also leave, be negated. And we only send from Canadian dollars back to either US dollars or another one of these in-betweens, euros, pounds, and pesos. Theoretically, you could send back to ringgits and rupiahs. However, that is going to be zero. I've just simplified the equation here. So whatever comes into Canadian dollars needs to then be sent out. And the same for euros, pounds, and pesos. We don't want any euros, pounds, pesos, or Canadian dollars at the end. We want all US dollars. So whatever is transferred through will be a Canadian dollar for a couple seconds, then be converted to whatever else we need to come down the path to eventually get US dollars. Lastly, and a very important constraint, is that we want to make sure that all money flows and ends as a US dollar. Now, similarly to these constraints where everything that came into Canadian, euro, pounds needs to leave, and similar to the initial constraints that we need to convert all yen, rupee, and ringgits, we have to make sure that everything ends up in the pool at the end as a US dollar. So these are the seven decision variables. We have yen to dollar, rupiah to dollar, ringgit to dollar, Canadian dollar to US dollar, euro to dollar, pound to dollar, and peso to dollar. These need to total 16,880,000. This value comes from the total sum of initial US dollars we had. We had 9.6 mil, 1.68, 5.6. That totals 16.88 mil. Everything that flows in needs to flow out a US dollar. So when we run this problem, the solution is going to be the cost to do all these transactions. To then find how much money you have at the end, you'd simply subtract this cost from 16,880,000. So as you can see on the left here, the total cost to do all these transactions was $83,380. Now, that's the cost. Again, the amount of money that you now have in your hands as US dollars is the 16,880,000 minus 83,380. So in the first step, the solution to part B, Jake would have $16,796,620 to then invest in US bonds. When we moved to part C, the transaction limits had been eliminated. The World Trade Organization said no transaction limits. So simply all we do is it's the exact same problem from B right here. However, all these constraints, the transaction limits, we then remove. So part C, very simply, it's the exact, every other constraint is the same. The problem is exactly the same besides removing those transaction limits out of rupiah, ringgit, and yen. So when we run part C, you'd expect to have a lower cost given that there are not as many limits and you can do fewer transactions. So as we see here, the cost of C is $67,480, which is obviously less than the $83,000 for flour. So the transaction cost is $67,480. You then subtract that from 16.88 mil to figure out how much you have to invest in US bonds. And you realize that you have $16,812,520 to invest in US bonds. Moving on to part D. Because the World Trade Organization said no transaction limits, the government of Malaysia decided to enact their own protection for their currency by making their transaction costs, any transaction with rupiah, being 500% of what it currently is. So what we do here is we take from Part C. There's no constraints of transaction costs, as there's still no transaction costs from the World Trade Organization. However, as you see here, the transactions that involve rupiah, which is my variable B, so B to A, B to C, B to D, B to E, B to F, B to G, are multiplied by 5. You're increasing the percentage of the transaction cost. Yeah, you're increasing the transaction cost percentage by 500%. So you're multiplying the transaction percentage by 5. So as you'd expect, this problem would have a higher transaction cost than Part C, where there was not this 500% increase. So let's run Part D. And as you see, the transaction cost is $87,640, which is higher than Part C. Logical, makes sense. To find out how many US dollars you have to invest in US bonds, you subtract 87,640 from the 16.88 mil, and you realize that Jake now has $16,792,360 to invest in US bonds by following this transaction costs with the 500% increase for the rupiah. Lastly, for Part E, just some things that Jake may not be considering is that obviously you've seen how quickly the rate of exchange can change. And so while he's making these multiple transactions and going through different governments, different countries, the exchange rate may be changing. So he may not end up with the exact amount of money that he estimated to end up with, as the exchange rate will be changing. Also, another thing to consider is that there may be transaction limits on the euro, pound, peso, or Canadian dollar. We were given transaction limits on the ringgit, rupiah, and yen, but there may be transaction limits on the other currencies as well. So that about wraps it up. Thank you very much, and I will now end the recording.